Jeff, I got this cool thing I could do with my phone.
Sure. Okay.
Yeah.
That's how he gets all those features.
Oh my God.
Yeah, exactly.
That's ridiculous.
Thank you.
What if it just snapped right now?
How do you do that?
All right. All right, guys. So no questions. Yes. All right, guys. I got a question. 8364.
I can put contacts in.
8364. Oh, good. So I think I can't remember if I said this. Where is it? Are there some? No, not really. That was different. I guess they don't have it. So, what's funny to me is chapter 9 is where they do geometry, but they do have some geometrical questions before that. So this one happens to be one about a right circular cylinder. 64? Yeah. Is that the 164?
Yeah.
Section 8.3. So a hot water heater is in the shape of a right circular cylinder. So let me know the formula for the volume of a right circular cylinder. For me, that's really pretty good. Very low standards for my artwork. Anybody happen to know the formula for the volume of a cylinder? What's the area of the base? What shape is the base in?
Circle.
Circle. So what's the area of the base? And I call the area of the base big ass B. You'll see why, because chapter 9 calls it big ass B. They don't actually call it big ass B, but it's a big ass B. That means the area of the base. What's the area of the base? What's the area of a circle? Pi r squared. Good. How are we doing so far? So can you imagine this is like a bunch of DVDs stacked up. So every DVD has an area of pi r squared, and how many of them are stacked up? Like H of them. So the volume will be the area of the base times how often that base is repeated. So it's pi r squared times H. So the volume of a cylinder is pi r squared times H. So what if this was a triangular shape and it was like a Toblerone, right? You guys know Toblerone?
Yeah, dude.
All right, if you don't, you should get to know Toblerone. Then I would do the area of a triangle times how long it is. It doesn't matter what the shape is. If it's a repeated shape, that's how you do the formula for the volume. It's awesome. So now they ask you, it's got a radius of 50 centimeters and a height of 150 centimeters. And they ask you, if the tank is filled with H2O, what's the volume in cubic meters? All right. So I don't know who asked the question. Did you know the formula?
No.
So that was the big question.
Yeah.
So just to make sure everybody can do the next step, to answer the question they ask, what should I immediately do?
Plug that information into what?
Sorry, buddy. I didn't mean to be so. I want the answer to be in cubic meters, but everything currently is in shit. So the very first thing I should do is change it into meters, so that when I do plug it in, it will come out to cubic meters.
Okay.
It's a very musical day.
So converted more is good.
Definitely, because again, I really want this to make sense. It's very easy to translate linear units, straight lengths, but areas and volumes. We talked the other day about how weird it gets to go from square to square, cube to cube. You got to cube or square the number, and you got to remember to do that. Oh shit! So before I do anything, I immediately convert them if they're not in the right units. Then when you plug them in, they're guaranteed to come out correct. Good. So that's all I'll do in that problem. So that should get people started. There's the formula for it, and then you do it.
Are we going to get those formulas?
Oh, yeah, I mean, if I put something like that on the test, I would give you the formula for it. Chapter 9, we're going to learn all the formulas for volumes and areas. So we'll talk then about what I'll let you know and what I won't give you. Yes?
Do you have practice test Monday?
I've got a practice test today. So, yes. Notice how I haven't given it to you yet. Haha. Yes?
Test Wednesday?
Yes. It's on your homework sheet. So on Monday, what's happening?
Review. Review that, review.
So many things I know, but for us it'll be, I'll have the answer key for the practice test and we review for the test. Just like we did for that first test. Okay, so, anything else from homework before we get into that last section? And we got one thing left in 8.3 to talk about, actually. Yes?
I just had a quick question about the test. So what do we need to have? Do we need to have like those formulas memorized and we're making a formula sheet?
Yeah, we'll make a
Oh, we're
formula
making a
sheet. Yeah,
formula
exactly.
sheet. Okay.
So on Monday we'll do the formula sheet.
Thus far, it's just shit. I don't know.
Just the shit.
King Henry.
Yeah, that you've got to know. That you've got to know. King Henry died
Unintentional.
unintentionally. I like
I
it.
just know.
Or whatever you like. King Henry died Monday drinking chocolate milk. King Henry died giggling for grams drinking chocolate milk.
I just say unexpectedly because he did it.
Yes, exactly. I love it. I never heard of it before. It's awesome. Unintentionally dying.
Which of the number systems do we have to memorized? Yeah.
So So on Monday we'll firm this up, but I should think I haven't given that to you yet. So I'm going to give you the Mayan base. I know there was a sheet I gave you that had some of the stuff on there.
You said everything but Romans. We have to know the Roman symbols and everything
Yeah.
else would give us.
No.
Besides maybe stipulations, but.
I'm going to give you the Mayan base, because the Mayan base is a little weird, right? I'm going to give you the Chinese symbols. I'm going to give you the Egyptian symbols. The Roman symbols, yes, you should know those. Let's see, what's left? Babylonian symbols you should know, because there's only 2 of them. Right? And the Babylonian base you should know. What's the Babylonian base?
60.
60. I like it. They're based on 60.
So, and then all the homework from this chapter, then like quiz questions and the test questions are due Wednesday.
Yes. In fact, it's all the homework from 4.1. This sounds like a ton, but you know it's not. 4.1 all the way to 8.4 is due.
Not the correct.
Just 4 chapters
But
worth.
the test
Yeah,
that-
corrections, homework corrections are not due until the day of the final. Test and quiz corrections are always due by the day of the next test. That's how you enter a room, I guess. That's right, you should.
So it's IBXLCDM. I just said it in my head enough times that it's stuck, right? IBXLCDM.
Yes, I like it. IVXL CDM, yes.
I'm musical, so I get the cadence. IBXLCDM.
IVXL CDM.
Yeah,
Okay, I
exactly.
like it. All right, whatever works. Oh, King Henry the Diamond. I'll stop singing. All right. Feel like, is that what that was, Jeff? All right. Somebody help me out. Who knows the freezing point of water in Fahrenheit?
32.
32 degrees. I like it. So water, H2O freezes 32 degrees Fahrenheit, which makes absolutely 0 sense. Celsius said, well, shit, let's just make the freezing point 0. I like it. All right? So 0 degrees Celsius and 32 degrees Fahrenheit are the same thing.
You want Kelvin?
Yeah, Kelvin is interesting. Anybody else know about Kelvin?
Who's Kelvin?
Lord Kelvin. Look him up. The Kelvin scale, if you hit 0 on the Kelvin scale, and actually I was doing research at Old Dominion University where we were cooling rubidium atoms down to almost absolute 0.
That's impossible, right? Absolute 0?
Yeah, absolute 0 is...
Wait, it's hypothetically possible.
Is hypothetically possible, but what happens when you reach absolute 0 is the absence of energy. And of course, mass itself is a form of energy. So there's all kinds of weird things. But you can get very close in the lab to absolute 0. And you know how we do it? We use lasers to cool them down. That certainly is counterintuitive, right? But I won't get into that. Sorry. It's enough of that. So yes, there's another scale of temperature that measures what temperature really measures. Temperature is supposed to measure how much energy is present. But Fahrenheit and Celsius don't do that. Because when you hit 0, can you not go any... Of course you can get colder than 0, right? If you live up in Alaska or up in, wherever, somewhere up there, I feel bad for you. I didn't even know the scale went as low as it does in some places. So water freezes. What about boiling point?
134 Fahrenheit?
212?
Yeah, 212 Fahrenheit, and Celsius keeps up the...
100.
Yeah, 100. 11. So, here we go. You ready? There has not been a lot of algebra in this class yet, has there? Right? I'm a math teacher, I got to show you some algebra. So let's make these points. When Celsius is 0, Fahrenheit is 32. When Celsius is 100, Fahrenheit is 212. All right, so it's like my Celsius and my input. So I'm trying to work out, when I get the equation of a line between these two, that will be the conversion equation between these two. So I can convert from Celsius to Fahrenheit. Right? Something I don't know if you even realized you're doing when you're finding lines. You could look at it as conversions between whatever x is and whatever y is. So what do I need for the equation of a line? What is the equation of a line? The general equation of a line. Who remembers?
mx plus b.
You got it. All right. So y equals mx plus b. And this form we can use because who remembers what b is? M is the slope.
Y equals
B is the y-intercept. Because when you make x 0, you get y is b. So when you don't move left to right at all, you go b. So that's on the y-axis. That's why it makes sense that b is the freaking y-intercept. And why can I use that? Because 32 is the y-intercept. When x is 0, y is 32. Right? So I know b is 32. Kick ass. Right? So what do I still need to know? M. I need to know what m is. Right? In fact, let's change this a little bit. What's my y variable really represent?
Fahrenheit.
Fahrenheit, 11. So let's call this F equals MC. And we'll go ahead and put 32 there. So all I need now is what m is. And who remembers the formula for slope? Rise over run. And the beautiful thing about rise is it rhymes with the y's. So it's the difference in the y's over the other guys, right? It's the only way to make it continue to rhyme. X doesn't really rhyme with run, so too bad for us. But so the rise, so what's the difference in the y's here? What's 212 minus 32? That's how much the y's changed. And what's 100 minus 0? I'll do that one. Yeah, Jeff. So 212 minus 32 is? 180. If you reduce this, bam, 9/5. So you end up with F is 9/5 C plus 32. That is the formula. If you know Celsius, that's how to get it back to Fahrenheit. How are we doing? So this is another formula you're going to have on your little formula sheet. So there's going to be problems in section A3 where they say if it's 20 degrees Celsius in Canada, what is it when you cross the border back in the U.S.? Plug a 22 in and figure out what it is. How are we doing? You guys all right? And the crowd goes, eh? All right. What about if I know Fahrenheit, I want to convert back to Celsius? How do you solve this equation for C? That's awesome. I love that. Sorry. That's a beautiful answer.
Why do we need mx plus b?
Say again?
Why do we need mx plus b? And why did you write it out like that? Like x, y intercepts?
So when the Celsius is 0, then the Fahrenheit is 32. So it sounds like when x is 1, y is 3 or something. It sounds like a point. So I can treat it like it's a point. So what I'm trying to do, like when we do this, that's a conversion between, if I know what x is, I can convert it to y by doing this to it. So the equation of a line is a conversion equation. You're converting from what x represents to what y. So if x was the number of hours you work, and y is the amount of money you make, your job sucks. You're making $2 an hour, but oh well. All right. Do you kind of see what I'm saying? Yeah. So if I look at these as points, and then I can look at more than you realize as points. Because when this is true, this is true. When this is true, this is true. They're points. Then I can find the y-intercept, I can find the slope, and I can create an equation. So this was really just the form of the answer, the form of it. So I don't want to use y.
What were you trying to do? I missed what you were even trying to do with it. You were trying to convert them to...
Trying to see a general equation to convert any Celsius into Fahrenheit. Because if it's 30, if it's 32, if it's 0 Celsius, I know it's 32. If it's 100 Celsius, I know it's 212. Well, what if it's 314 Celsius? What's that in Fahrenheit? Oh, shit. So, but now I know I just plug a 314 in there. And then I can figure out what the Fahrenheit is. You guys kind of with me? Yes.
So to figure out Celsius, would you just plug in Fahrenheit, or do you need an entirely new equation?
The funny thing is not entirely an equation, it's just this equation rewritten, right? How do you start to solve this for C? Who remembers the first good thing to do? Subtract 32, so you get F minus 32. Anybody remember how to kill? I want C by itself. How do you kill 9/5? Sort of, so you multiply by the reciprocal. So multiply both sides by 5/9, and you end up with C equals 5/9 times F minus 32. How we doing? So let's do this. I just thought about something. Beautiful. I love it. Stop. Sweet. How you guys doing out there? You guys all right? Again, what's really funny to me is this is how we made these equations. So now what is on your shoulders is to write these equations down and know how to use them. I always want to show you where things come from. Has anybody seen these equations before today? Anybody ever seen these equations before today? Thank God. All right. I'm hoping some of you at least have seen these equations before today. So look, I just looked up the temperature in Nome, Alaska. And yes, there is a Nome, Alaska. There it is. So the temperature right now is negative 10 degrees Celsius. I could click on that F and make it Fahrenheit, but I won't. Take a second and tell me, figure out what it is in Fahrenheit. So that is negative 10 degrees Celsius. I want to know what that is in Fahrenheit.
Where is that Nome,
Alaska. Yeah. Yeah, Arkansas won't quite get that cold. Not yet.
Because I got how you into it, why I'm not sure on that part. It's just like, why? It's just, but if I want to find Celsius, if I want to find Fahrenheit, you just like,
Alright, so which version of the same? There's only one equation up here. I hope you guys realize. I've written the equation like that. I've written the same equation like that. There's one equation written two different ways. Which version am I going to use? First one. That makes sense because I know C, so I want that to be the input. So F equals 9/5 times negative 10 plus 32. 5 goes into 10 twice, so I got negative 2 there, right? 9 times negative 2 is negative 18 plus 32 is 14. And sure enough, if I click on the F, up, yay! So I love it. Some of you guys are like, just click on the damn button and shut the hell just show. Yeah.
Why do you use those numbers like F equals 9 over 5, C plus 32? Is that just because of the quote? Never mind. I think I just got it. The whole thing.
She just got it right now.
Never
All right.
mind, I just got it.
Good.
Forget it.
All right. That's awesome. I love that. The wait and see approach to teaching.
There's a city called Nome.
Yes, there is.
Pretty sure that's where I'm from.
It sounds like.
That sucks. It was mostly sunny there too. It's terrible.
Mostly sunny at negative 10
Yeah.
Celsius.
There's no Alaska. Way down there. I don't think there's much of a population there. They have an airport. And they have like I think they have 2 traffic lights. Yes.
Can you
Go to Street View, the Earth View, dude.
No, I'm not. We're going to continue. All right. So that's the last part of section A3 is these 2 equations here.
We gotta go Street View. It's gonna bother us. We need to see. We need to know what
Yeah.
it's really like on the inside.
All right, that's your homework. Just remember when you spell this, it doesn't have a G. They have a place to eat. Airport pizza is the name of the place. Oh my God. I'm sorry. Look at that. It's a ruler for some reason. And I search for
Airport pizza.
All right, let me see. Oh, you asked me the other day about
It's not even
names. I don't know if you even looked it up, right?
I did.
You did?
I did. After trillion is quadrillion.
Quadrillion.
Quintillion.
Quintillion.
Yeah,
I like it.
quintillion, yeah.
Sextillion, octillion is up there.
Heptillion.
It's
I think.
crazy.
Yeah.
And if you go crazy big, I mean, so this website shows you.
That sounds a little sensual.
And this is where Google got its name. I don't know if you guys know that. They misspelled it, but oh well. It's too bad for them.
No.
I'm Google. Sorry.
Yeah, what's the very last one?
Look at this. Quatersexagentillion. Yeah.
I wish
But real quick, notice this. There's a numeric base converter on this page, so it's kind of awesome. You plug in a number,
How do you think I did all my homework?
and then you change it. Thankfully, you showed me it works. So that's good. So this guy. There's another side that shows you the steps.
For the homework, it's 8-1. When we show our work, do you want to draw like a K, H, and then do little dips to show like it says like 9 grams to hectograms? Like you want to, because I know we just write it, but you want to show us the
Well, you don't have to do it each time, but it would be nice if I saw that somewhere in your paper and I could see like pencil marks to show me that you were doing something. Yeah. All right. So section H4 is actually nothing too new. I keep turning the light off and I keep needing to talk to it. Let me ask you this. Does anybody know how many centimeters are in an inch? Yeah, 2.54. Yeah, and it's up there if you look at it. So 1 inch is 2.54 centimeters. So I have a ruler up here because I didn't bring one with me. Oh well. But I keep doing this. That's 12 inches, right?
Yeah, it is.
Yeah, dude. All right, just calm down. And if you turn that around, of course, there's centimeters. So 12 inches is equal to, what's that look like? How many centimeters? 30.5, just about, right? So 12 inches is 30.5 centimeters, it looks like, from just looking at the ruler. You guys kind of with me? I like it. So it's almost right. How can I check that? So this is a question mark, because I don't know. This is a question mark. But I know this is true, basically. So how do I check this? That's 1 inch is this, so 12 inches, what do I do?
12 times.
Multiply by 12. So 12 inches, and what's 12 times 2.54?
30.49. 30.48.
There it is. All that goes on Price is Right. Hi, Laura. All right, now, let me show you this last piece that kind of irritates me. In the book, they've got a very helpful looking box. But can you find what's related to what we just did? Look right at the top here. 1 foot is, what do they say?
30.
And to be honest, that's way off. Because if you had 5,000 feet and you want to convert it to centimeters, you use that, you're going to be off by half of 5,000 feet, which is a lot, right? Do you guys understand? So I on the page before this, they say, well, some of these are approximations. I'm like, you have room. Why did you have to approximate it so much? So when you're doing your homework, if you use that number, okay, because that's what the book said, but I'm trying to show you this is what that should really be. It should really be 30.48.
What's funny is they didn't do it with the centimeters. They're like,
Yeah, the 1 inch,
exactly or
the 1 inch to centimeters are fine, and then the foot they're like, I don't want to do another decimal. What? It doesn't make any sense. There. Anyway, so now we've done some conversions before. So 8.4 is nothing new in the sense of a procedure to follow, but it's new because now we're talking about converting from our system to metric, right? And those conversions have got to be disgusting because one is based on reality and the other one's based on a king's foot freaking size. So there's going to be some problems converting. I'm not bitter. So for example, let's remember how to convert stuff. So leaving it up here. So 1 foot is 30.48 centimeters. And 1 yard is how many feet?
3.
3 feet, I like it. And 1 mile is how many feet?
Or 7,000.
280.
Yeah, 5,280 feet. And I think they have that in a box on the next previous page. There it is. Yeah, they have 1 mile there. It's 5,280 feet. All right, so if I had to go, what you got, Jeff? 0.93 miles. How many centimeters would I have to go?
Oh.
So take a minute and try to figure that out. I love it because some of you guys are like, who is this person that has to know this? It's me. So do it. It's the same guy that doesn't remember how much money he put in the bank from algebra. Did you hear that? Yeah. Oh, okay, good. Well, it's just in my head. I teach my morning class. Whoever teaches next to me is so loud. I'm like, my students get 2 classes worth of information. I'm like,
What's centimeters 2.5 per inch?
yeah, but you don't really need that.
I'm trying to get to centimeters?
Totally. But if you go to miles to feet and feet, go straight to centimeters. Yeah, dude. You want it. But it would still work that way. It would work that way all day. So just in case somebody's freaking out, I am going to give you this on the test, right? I'm going to just give you a copy of this box. You just have to know how to use it. Probably going to cut and paste the correct number there. Do some really deep Photoshop. Let's see. All right. So what's my path going to be? I can go from miles to what? To feet to... All right, so my path is very short. I like it. Kick ass. So you could go inches and then to centimeters. You could add one more route off of your path. Let's not do that. So 0.93 miles. Who remembers how to do this? We've done some stuff like this before, but now it's going to rule your life in Section 84.
Right?
Well, let's see. I want to get rid of miles, right?
Yeah.
So where am I going to put it? Up here or down there?
Bottom.
On the bottom. So, and miles to feet. And then I want to get rid of feet.
Put it on the bottom.
Put it on the bottom. So that'll kill feet, and then I'll end up in centimeters. So now you just put the numbers next to the units. So 1 mile is 5,280 feet. And 1 foot is 30.48 centimeters. And this process, just make sure you multiply at the right time and you divide at the right time. Because it's really a question of, do I multiply or divide? That's really what conversion comes down to. This box kind of way to do it, make sure if it's down here, you divide. If it's up here, you multiply. Right? So anybody do that yet?
Yeah.
Fucking that big number. 149,668 point.
992.
Yeah.
I like it. Cool. And we should expect it's almost a mile, so it should be a decent number of centimeters when you chop that thing down. This process is all you got to know. I'm going to provide you with this. I'm going to expect you to know freaking 12 inches in a foot. I'm going to expect you to know 3 feet in a yard. If I put something down there that expects you to know that you happen to not know, you just got to come up and ask me. Right? And I'll just harass you for a little bit, and then I'll tell you. Let me see if there's anything else I forgot here. Not really. Okay, good. I like it. So here, let me give you guys the practice test.
Wheels. Like wheelies. Like wheelies. You got wheelies? You want wheelies? Wheelies? Yeah, the shoe with the wheel.
I know.
The wheel.
And then make him an adult
Yeah.
size.
You have a pair. You have a pair of those, or did you? Ever have one?
I thought about it a while back, and then I'm like,
As an adult?
yeah, that's why I
Just zipping around the store.
decided not to.
Honestly, I imagine that wearing adult diapers and adult Heelys.
Whatever you want on your bucket list.
It's gonna be off my bucket list pretty soon.
Imagine you see like a full ass grown man rolling down the street. Out of business in every phase.
All right, guys. If you were not able to turn something in today for your project, email me something over the weekend because I want to be able to give my notes back on Monday, so you have time to look them over and incorporate it into your system. Cool.
All right.